GM everyone, and welcome back to another Secret Network Cosm Wasm developer tutorial. In the previous video, we learned how to write our first Secret Network smart contract, and now in this tutorial, you're going to learn how to actually upload, instantiate, execute, and query your secret contract on Secret Network testnet. So let's dive in. So before we go any further, I want you just to take a look at the Secret Network documentation. This is the place, the source of truth for everything happening on Secret Network and having to do with Secret Network development. The best place to get started is just this Get Started tab here, where you can learn how to do exactly what we're going to do today, which is compiling and deploying a contract on Secret Testnet. I've also created this repo for everyone who's watching this developer series called Secret Network Cosm Wasm Developer Tutorials. I have the repository linked from our previous video where we learned how to write our first Secret Network smart contract. In this video today, what we're going to learn how to do is actually upload and instantiate that contract on Secret Network testnet. So let's do exactly that. First, what we're going to do is just clone this repo down to our machine locally. So this is called github.com, writers blockchain, Secret Network Cosm Wasm developer tutorials. So I'm just going to clone it to my desktop. Wonderful. Let's pull that open. And if we open this first tab here, we'll see the contract that we wrote in the previous video. This is just our contract where we can store a password and a key map on secret in the secret contract. And what we're going to do today is actually upload this contract on chain so that we can test doing this with secret.js. So the contract exists in this folder, Hello World, and the repo we're actually going to be working with today is here, Hello World secret.js. And this is where we're going to learn how to upload and instantiate our contract. So before we go any further, actually, let's just jump back to some documentation. So secret.js is the Secret Network JavaScript SDK for interacting with Secret Network smart contracts. We have a whole section in the Secret documentation for front-end development if you want to learn how to get started with secret.js. Another great place is you can just go to the GitHub repo for secret.js. So if you look up like secret.js, secret documentation, you'll see Secret Networks documentation, and you'll also see this repo here. I'll make sure to link to this below. We're going to be using a lot of this code here today. So this just walks you through all the different methods and things you can do using secret.js, how to get it connected to MetaMask or Kepler or Fino Wallet or many other wallets you can use like Starshell or Leap. Let me start by seeding into our secret.js repo. The first thing I'm going to do is just install all of the dependencies. And if we go to this package.json file, we'll see we only have two dependencies here. We have secret.js and we have our .env here. So secret.js is how we just gain access to the secret.js SDK. And I've already created an environment variable here today in this .env file with a test wallet with test tokens. So whenever you are experimenting with just using testnet, never use your real wallet with real funds. Create a new wallet where you can have access to testnet funds. And before we go any further, let me just teach you how to actually use the Secret Network testnet faucet. So if we just search, I think probably Secret Network faucet. Here you go. We have the Secret Network testnet faucet here. So I'm just going to copy my address, continue, confirm that I'm not a robot, confirm I know what a car is, and it'll send us 100 secret testnet tokens, just like that. Great. So now we have a wallet that we can use to upload and instantiate and execute our contract. So I've already written this upload script for you so that everything comes pre-configured out of the box. What you need to know here is we import from secret.js SDK this Secret Network client and this wallet. And then here we are just configuring our .env file. So let's look at this line by line. So starting with our wallet. So this is just how we get access to our wallet here. So it's just accessing this mnemonic string that's in our environment file. If you don't want to do that, you could also just take this, your wallet string, and you could just bring it in here like this. This line 8, is reading the compiled contract file. So before we go any further, let's actually compile our smart contract from the previous video. I'm going to create a new tab here. I'm going to cd into our hello world. And then to compile that contract, I'm going to run make build mainnet reproducible. We're compiling that smart contract using this make file here. We're just running this script right here, make build mainnet reproducible, which runs this Docker script. So if you get any error here, it's probably because you don't have Docker installed on running on your machine locally. So just make sure you have Docker installed if you receive an error. All right, and then once it's finished compiling, it's gonna output this file here, contract.wasm.gz. This is the compiled smart contract. I'm just gonna take that, I'm gonna copy it, and I'm just gonna paste it into here, into our Hello World secret.js folder, so we can actually upload that. So if we go back to this upload script, we see that it's expecting this contract.wasm.gz file, which we have just pasted into this folder. This is how we actually access the file that we're going to be uploading to the secret testnet. Next, we create our secret network client. So this is what we're actually using to connect our wallet to the testnet chain. And we have to import a chain ID and a chain URL. If you want to do this on mainnet instead of testnet, all you would literally need to swap out here is the chain ID and the URL. And all of that can be found in the secret network documentation. So if we go back to the documentation here, and there's this area right here called deployment addresses, API endpoints, connecting to the network. And then we have API endpoints for testnet as well as mainnet. And today we're doing this for testnet, and we're using an LCD address and the testnet chain ID, which is pulsar3. So if you want to do this for mainnet, you would just use the mainnet address, which is secret4, and then one of these LCD endpoints. And then it's just using our wallet and our wallet address from this wallet variable here that we created using this import wallet from secret.js. All right. So this script that I wrote, it's going to upload and instantiate our contract in one function call here. Let's just walk through what the upload function does as well as the instantiate function. All right. So if you look at this upload script right here, it's exactly how you would see it in the secret.js docs. So if we go back to the secret.js docs, we control find for upload. I'm just taking this code right here and pasting it in here for our purposes. And same thing with instantiate. You can see how to do that here. And in this example for the instantiation, it's actually showing how to instantiate your own secret token, which is another video that we'll get to eventually. So we are using this compute method with store code. We have a sender parameter, which is the wallet address. We have the actual contract code, which is that compiled contract that we're pointing to. Source and builder, you can just leave as blank strings. We set a gas limit. And what this is going to return is a code ID as well as a contract code hash. The code ID and the code hash are unique to each smart contract. So this smart contract that we're creating, the contract code hash is actually generated from the contract itself. So if we kept uploading the same contract over and over again and we didn't change a line of code, we would get the same compiled contract code hash. As soon as you change the code, it's going to generate a different code hash. And then each time you upload, it just increases the code ID by 1. And then what we do from here is we can instantiate the smart contract. You have to have a code ID and a contract code hash in order to instantiate. So we say if we don't have a code ID and code hash, throw an error. And then instead of using the store code method, when we're instantiating, we're using the instantiate contract method now. And we have to pass a few parameters. So we have to pass the code ID, We pass the sender, which in this case is the wallet we established above. We pass the contract code hash. We pass the instantiation message. So if you remember in the previous video, we have an empty instantiation message. So we can just look at that contract code. We go to the message and we have an empty instantiate message, which is why we're going to instantiate our contract with an empty instantiation message. But if we had written this smart contract with an instantiation message, like for example, an admin, or if there was information about a token that we are instantiating and we had all that information here, we need to make sure that we also include that when we instantiate our smart contract. But in this instance, we can just keep it blank. We have a label, which we can name whatever. You just have to make sure that your label is unique and that there hasn't been that label used previously for an instantiated smart contract. And then we have an admin, which we're setting as our wallet address, and again, a gas limit. And upon successful instantiation, this will return a contract address. So when we call this method using npm, or when we call this script upload.js, what we should do is upload and instantiate our smart contract. Let's try it out. Great, we got a code ID and contract code hash returned, and a contract address. Here we go. So now our smart contract, our hello world smart contract where we can store a password, now exists on Secret Network Testnet. So now let's actually test using it. Let's try to store a password and then query the stored password that we've written. So what I'm going to do is I'm just going to copy this address, and I already wrote two scripts for us. I wrote a query script and an execute script. So let's start with execute. Anytime you're executing or querying a smart contract, you're always going to use Secret Network Client. So in the same way we use this to upload and instantiate our contract, we also use this to execute and query. You'll see we point to the same chain ID and URL. And one thing that's different here is now we are actually pointing to our contract code hash and our contract address. So let's add these to our environment files. So I'm going to open that .env file again. And I'm going to say that this is our contract hash. And this is our contract address. Awesome. And now, using Secret.js, we're going to actually store a password in this smart contract. And now we're using the method execute contract. So this should look just how it looked with our instantiation script, but instead we're now accessing a specific method in the smart contract. And I think we only created one method, if I remember correctly, this store password method. So let's see. So any method you're going to be calling with Secret.js, it needs to match the method that you wrote in your smart contract. So if we go back to our hello world smart contract and we go to the messages, we see that we have this store password method, right? And note that when we compile the contract, we use this snake case to rename everything. So that's why we have to use snake case when we actually construct this message in our execute script. So store password, right? Store password. This is the message that we're going to be executing. And what we pass to that is a password key and a password value, both of which are strings. So let's do exactly that. So we can call this whatever we want. I'm just going to call this, the key is Sean, and the password value that we actually want to store, I'm going to say is secret. So when I pass the word Sean, it's going to return the password value secret. And again, all this is happening inside of secret contracts, which use a trusted execution environment. So all this information is being encrypted on chain. And then we pass the contract code hash and a gas limit. And if this is successful, what it should return is the array log of the transaction. Let's try this out. I'm going to call node execute in order to run this execute.js script. And then what's returned is a bunch of information about the transaction. This should look familiar if you've ever worked with Cosm Wasm before. If not, that's okay. I just return some basic information like who called the contract, what's the contract address, the gas used, the gas wanted, etc. All right, so we just stored the password value secret on chain, which can be retrieved with the key Sean. So let's go to our query now and actually try to use that. So again here, what we do is we establish our secret network client. We point to our contract address and code hash, and then we construct our query message. And now we're still using our secret.js client, but instead we're using this query method with query contract as the method. So we point to that contract address, to our contract code hash, and then we have to say which query we actually want to call in the contract. And in our contract, we only wrote one query message, which was get password. Again, this is going to be renamed to snake case, so it's going to be get_password. And we'll see that here in our query script. Get password. And then we have to pass a password key in order to return the password value. Right? That's how we define that here in our query message. You pass a password key, which is a string, and if you pass the correct key, it should return your password value. And it returns it in this struct password response. So let's try that. So if we do something arbitrary, this should fail because it's the incorrect password key. So I'm going to run node query to call this query script. And it tells us password key is incorrect. And it even uses the error message that we defined in our contract. If you go back to the contract and we go to our query password function, we say return it, or if it fails, use this generic error that we defined, which is password key is incorrect. So that's all working. That's amazing. Now let's try it with the correct key value pair. So we're going to say use the password key Sean, because that's what we just established with our execute function. And now it should return the password secret if this is successful. There you go. And we can keep doing this over and over again with any sort of passwords or information that we want to store on chain. All right, everybody, that has been our Secret Network CosmWasm developer tutorial. Today we learned how to use the Secret.js SDK in order to upload, instantiate, execute, and query our smart contract that we wrote in the previous video. I hope this was informative. If you have any questions, just post them below, and also join the Secret Network Community Developer Telegram group where you can ask questions and get feedback from Secret Network developers. In the next video, we're going to learn how to actually make a full stack Secret Network application using Secret Network RNG, Secret Network VRF. So you're going to learn how to get randomness on chain from Secret Network and how to access that in a full stack application. Be sure to like and subscribe to Secret Network for more developer content to your inbox weekly, and I will see you next week. Thanks so much, everybody.